So we'll look at different kind of conditional statements now. In other languages, these statements are called case statements or switch statements. StructureWare calls them select statements. Essentially, what we've got here is a very small program that takes a code from a Camus boiler and it translates it into its corresponding error message. So what we've got here on the StructureWare side is we've created a code analog variable. This code is going to come in the range of like 1 to like 50 or 60 or 100. So you have code 1 means this. Code 54 means this. Code 75 means that. And so that's how that works. So we've got the code that we get from the boiler through, say, a BACnet integration, for example. And then we have the specifications for the boiler. We got the point mapping schedule from the manufacturer, so we know what the codes mean. And we want to present that in a way for the customer, for the end user, so that they can see, instead of a number that means nothing to them, like for example 213, error code 213. Okay, now they have to go find the documentation. They have to figure out what 213 is, or call somebody. Instead of that, they can just get a nice clear message, which is what they would get if they were to go get the documentation and try to search for code 213. They'll get a message eventually, and that's what we want to display on the user interface. So the way I put that together would be this Camus status program, which we'll open up bindings for now, and then a function. So functions, this is looks like a script but with a little yellow gear. The way you create functions is, as we saw before, is just another choice under this menu of choices. You'd select that, and it's basically, you create it just the same way you create a program. And then your function typically will take input in the form of arguments, and it will return a value back to the program that calls that function. So in order for, and this is kind of what this looks like. So here we're calling burner status, and we're giving it an input, which is the value stored in the B1 code variable, which is bound to this B1 code analog point or value in StructureWare. So the way this would work is this would be a BACnet value coming back from the boiler BACnet card, and then the boiler would go into error, and it would write the error code value to this point, and then we would take that as an input into this function, and then that function does something with this code and it returns a value. So you can use this function that returns a value after it processes the input. You can use the function itself as you would a variable, and the returning value after processing this function is essentially the same thing you would get as the value stored in a variable. This is another operator, though it's specific to the StructureWare and BizScript language. This is not an operator you'll see on any other language that I know of. We're talking Java, C, C#, C++, JavaScript, Python. None of those languages would have this type of operator. So this is very specific to StructureWare script. So essentially this is an assignment operator that has two operators in one and takes two operands. So it's set B1 string, so set the value of B1, the B1 string variable, to the value returning from burner status, the function. So this set B1 string to burner status is exactly the same. It'll result in exactly the same value as doing this. B1 str assign burner status B1 code that we've been seeing all along throughout the series of videos. These two statements generate the same exact result. They do exactly the same thing. This E line here, it's an error line, and the code in this subroutine will only execute if this error property of the program object displays an error or something other than success or idle. In that case, this E line would automatically execute whatever's inside of it, and in this case we just wait 30 seconds and then go right back to the only other routine or subroutine line in this program. So now that we know how to use the function, we'll look at how we had to bind this function variable called burner status. We had to actually bind it to the function we created, the function object we created in StructureWare. And then this is how we did that. Here is a function binding created by this function variable declaration in the program that we then went ahead and bound our function object we created in StructureWare right to it. So then we can go ahead and click edit on that function, and then that'll show up right here, and this is what that function looks like. So the arg1, this would be the only argument this function takes, which we'll call code input. You could have arg2 and arg3 be whatever you want it to be, and that's how that would go. If you declare something with a data type, a variable with a data type, but without an argument, without this arg keyword, then it'll be a local variable that will only live within the scope of the function, and it cannot be referenced anywhere else outside this function. Similar to when we called, when we declare variables here without a binding modifier, it will not be a binding variable. It'll be a variable local in scope and only referenced within the program. So in this case, we're using a select case statement. Now this select case statement, we could have done the same thing with if-then statements, but this seemed to me like a much more elegant way to accomplish the same thing, and less code probably, easier to understand, and just a cleaner way to do it. However, if you were trying to accomplish something like this on B3 controllers, then this is not available to you. So you would have to do something like this with if-then else statements. We went into the point mappings. We found the code backnet value that's coming back from the backnet card, and we found the section where it describes the different messages you can get, and then this is how I code this. So basically, when the argument, the only argument of this function takes an input that is either 0, 1, 4, 5, 34, 35, any of these different possible codes, this is the message that will be generated, and this message will be assigned again to this string local variable we've created here, and then at the very end, once we get a match, we'll return that value out to the calling program through this return statement, and it'll be the value stored in str. Now, there is always a likelihood that something happens and we don't get a match. And in order to account for that possibility, we have a case else statement that we set to a generic message that basically lets the user know that there was an error and we couldn't resolve that code that was sent as an argument to this function as anything, and therefore we return this message. We decided to call it undefined status code. Now, these are string data types, and string data types are sequences of string characters or ASCII characters for this. Strings are always enclosed in double quotes, and they have some specific functions that we'll go over on a different presentation about functions. And so that's it. This is how you code a function. You always need to have a return statement if you want your function to return a value. Now, if you just wanted to figure out, I don't know, if you just wanted to do something with your arguments, or you just wanted to do something, you don't want to return a value, that's okay too. You don't have to return a value to run a function. But if you want to return a value, you need to have a return statement, and you can only have one return statement. If you were to put anything here, it would be ignored. Any code here, even if it's valid code, it would be ignored, because once the function hits a return statement, it stops executing the function, and then the function gets erased out of memory. A function doesn't have to have arguments in order to run. It doesn't have to have any input. It could just do something random inside it without requiring any input. But if you were to code arguments, this is how you would do it. And then this function, now that got bound, it got declared as a function in the calling program, which is this one. This is the program that calls that function into memory so that it would execute the code within it and return a value based on the input arguments and the return value at the end. This is the program that calls that function, and so you have to be very careful to provide the same number of arguments here that you specified or declared inside the function. The data type has to be the same, obviously, otherwise this is not going to work as well as you want to. And if the debugging programs is not easy, debugging a function, you can't see, you're absolutely blind when you write these functions. The only thing you can see is whatever you get out of the function through this return statement. You cannot debug or see any variables, and nothing happening inside your function. You have to make sure that the data types and the order of these arguments are correct, and you have to make sure that if your function returns a value, it will be the value that this data, the same data type as the variable that is going to store the value returned by the function. So now if we were to run this, let's do a trace, we'll come here, see what value we've got. So we've got that. Now if we change this to 1, then that's what we get. There you have it.